Good afternoon, everyone. Assalamualaikum. My name is Maykhel. Or CCTVs, we are now able to gather as much data that we can, or vast amount of data, and the introduction of AI enables us to further analyze or improve analysis based on the data of the ANPR. So yeah, my name is Maykhel de Leon. I'm the head of the product development. So what is ANPR? ANPR stands for Automatic Number Plate Recognition, that uses optical character recognition or OCR to process images from CCTVs. Here, what you can see is an example of a number plate that's been captured by ANPR. Now, how the ANPR process this image? Right. So first, we have the real-time object detection, which allows the ANPR to detect objects such as vehicles, and then identify or classify it further, or which part of the vehicle is the number plate. And then after that, after the object detection, now that we already identified the location of the license plate, we will now proceed with the image processing, wherein we will process further the image. We will extract all the information. For example, here what you can see, there are multiple characters, like for example the license plate itself, the country, also a website, and anything else. And once we undergo or finish image processing, we will now proceed with the optical character recognition, or the OCR, wherein we will extract this alphanumeric characters from the license plate. Once we have that, we will now further proceed with the final stage, which is the template matching. Template matching, wherein if you have a database of license plates, you will compare your processed image into that database so that the accuracy of the model will be improved. So what you can see here is the metadata generated by ANPR camera. So there are very important details into this, like for example the camera location, camera direction, the latitude, the topology, and so on. So these details are very important in terms of if you want to process further or apply AI into your ANPR data. So what you can see here is an algorithm that we have, which later on we will explain the process behind it. So basically, you can see on the first figure 1, this is what we call the overall or the complete journey of the vehicles, from coming or being seen from camera 1 up to camera 6. So that's a complete journey. Then the second figure demonstrates the appearance of the vehicle from camera 1 to camera 3. That's what we call a session. Then if there are a gap between that, and then on the camera 4 to camera 6, there's again a recording on the ANPR, so that would be the session 2. And then what you can see in the last figure is the occurrence or appearance of two vehicles at the same time. So you have vehicle A and B, which has its own distance to each other, and also the time that they are recorded in the ANPR camera. So these are important, especially with the product that we are doing, which I will later on describe. Now, what is the role of AI, HPC, and big data? So basically, these are the three main ingredients if you want to do AI. First of all, the data is very important to have. The next one, you need to have your algorithms, right? Which is probably AI, or it could be different neural network application or machine learning algorithms. And the last one is the HPC, which enables you to train your model in a fast manner using what Hamad has explained earlier. We have the Mahar that we use to model the vast amount of data that we have. So, one of the two use cases that we're currently developing using the ANPR algorithm that we have is the tailgating use case. So basically, in the UAE, there are some instances that, as you can see here, there are 45,000 tailgating incidents recorded in 2021. So that's quite a lot. And these are currently recorded or being observed manually. So if you are a desk officer sitting in your traffic monitoring center, you are facing a monitor, so you would run maybe historical recording of the day of the NPR, and then you will see if there are occurrence of tailgating, so it's quite manual. So the algorithm that we have aims to capture this kind of incidents, wherein you have the tailgate incidents, like these vehicles. Sorry, that's not it. This is actually a video, so let's just see if they can play it. So this is another example wherein we are detecting stolen vehicles. So basically in the UK, it's a very prominent problem wherein a lot of cars being stolen by organized crime, wherein it's costing them a lot in their economy. Right? So basically, an organized crime steal your car and they drive off. So they form a convoy, could be 2 or 3 cars. So that type of behavior is different from just you and your friends traveling together in a convoy as well. So that's a different story. Those type of driving behavior can be captured by our algorithm. So here, for example, Rob is a normal citizen who has this normal driving pattern from going to work and going back home. And those two criminals are just roaming around trying to find their next victim. Right? So those type, you can call this all journeys from day 1 to day 5. So now they spotted Rob going to his home that he's parking his vehicle onto that location. So they just waited there for Rob to come back and actually steal his car. So now they are now traveling in a convoy and they're going to a garage, which is the middleman. And then afterwards, the vehicle could be sold into different places abroad, or could be cut into pieces, or they can use Rob's vehicle plate and attach it to other vehicle and do more crimes. So I know this is not the case in the UAE, we don't have this problem here, but what I'm saying is the algorithm can be used in different use cases such as the tailgating. So here, on the proposed solution of the algorithm, we have advanced ANPR algorithm, which is enable us to detect this kind of behavior. So that we got the algorithm from University of Kent in the UK in the process of tech transfer, which is my colleague will explain later on. And the second is real-time and historical analysis. Because if you detect this kind of behavior or incident, it's very important to act fast and act in real time. To be able to do that, you need a very high compute processing hardware. And we have also alert and notification system, of course, to alert the authorities once these incidents occur. And we also have data security and privacy, which assure you that your data, while it's confidential, is secured and being taken care of. There are also integration capabilities wherein it could be integrated into the different systems of the police forces as well. And there is also a cross-referencing database wherein we can integrate the system into specific database. For example, police has a database of criminals or criminal cars which has been recorded previously. And we also have the feedback loop wherein the machine will learn from new data without explicitly coding it again. So expected outcomes, reduction in vehicle thefts and actually increasing the fines for the tailgating incidences, and then enhanced public safety wherein we can minimize this kind of stealing of vehicles or tailgating incidences, and of course lastly the efficient law enforcement using the algorithm. So that would be all from me. Thank you.